So I'm going to take a couple seconds to go over problem K from today's assignment. It's nothing you've seen, parts of it you've seen before, but I think now that we're adding limits into it, it's a good time to talk about what this actually is. So you guys will know, I'm going to highlight it in pink. This hopefully looks familiar. It's what we call in Precalc the difference quotient. And when we were doing composite functions, we used it quite a bit to simplify and figure out how to, figure out how to simplify it to something that usually involved an h. Now with limits, it becomes something different. It becomes the limit definition of a derivative, right? And so see this function right here, it has a derivative, and we'll talk about that in the coming chapter. But for right now, keep an eye on that this is your f of x, and this thing, I'm gonna box it in blue over here, is your f of x plus h. And we've already assessed on this. You guys are pretty good with being able to simplify that. So since this is a limit problem, we're going to start as always. We're going to plug in 0, and we're going to get 0 over 0, which means something can be factored out. It's a running theme of this lesson. So I'm going to write the limit as h approaches 0, and I'm going to just try to simplify the top. See if we can find an h that we can get out of there. I've got x squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x all over that little lone h. So let's start canceling some things out. I've got an x squared here and a negative x squared here, so that can go. And then I've got a minus 3x and a plus 3x, so that's going to go. And what you'll see happen is you'll be left with terms that all have an h in it, which is perfect because then we can divide them out. I'm going to reorder these a little bit. Okay, and so when you have a lone term in the denominator, you can divide each term separately by what you have in the denominator. So I have an h here, that's perfect. I have an h here, I'm going to take away one of these. That will get rid of a whole h over h. The result will be the limit as h approaches 0 of 2x minus 3 plus h. I'll plug in for this lone h left, and my answer will be 2x minus 3. And that is what will be the derivative of x squared minus 3x. Okay, I think there's another one in your assignment today. Certainly try it, and if you have any questions,